So another class on loops. The program which which I have given you, that is write a C program to display all two-digit numbers which are divisible by 3 but not divisible by 9. So this was our question. So in the question, it is clearly written as we have to display the two-digit number. So first criteria, number should be of two-digit. Now condition is which are divisible by 3. That means num mod 3 must be equal to 0 and but not divisible by 3, and the same number if I divide it by 9, then it cannot be completely divisible, that is not equal to 0. So these are the three parameters on which we have to write the program. So starting with our header file and our main function, then first task is to variable declaration. So as in the question, it is clear that we have to take only two-digit number. Okay, so no need to write any variable which will take number of term as we took in the earlier program of series. So here what will be the declarations? That is, we have to store the first number. Okay, so I mean first number of this series. This is also a series, that is two-digit number. The series of two-digit number is starting from 10, right? 10, 11, 12 up to 99. Okay, so this is the series. So first take our first term and initialize it by 10. That is the first two-digit number is 10. Okay, now uh, take a while loop. Okay, the what will be the condition? That is, condition is we have to take all the two-digit number. The condition is we have to take all the two-digit number. Okay, so a will be less than equal to 99. This will be our condition within the while loop. That is, this loop will run from a equal to 10 to a less than equal to 99. Okay, so between 10 to 99 we have our all the two-digit numbers. Now we have to check every number whether it is divisible by 3 and not divisible by 9. If it is, then we will print the number. So we can do it we can do this program in two ways. First way is this: if a mod 3 equal to 0, okay, if it is true, then we will check if a mod 9 not equal to 0. If this is true, then printf %d, then give a tab and print a. Okay, and then return 0. Now see how this program runs. First a is 10, so while loop goes true, that is for a equal to 10, a equal to 10, while loop will be true. Then if a mod 3 equal to 0, that is 10 mod 3 equal to 0. No, that is false. So as it is false, then this block of statement will not run. The control will come directly here, and after this loop, so control will come again at the while loop. Now here a will be incremented, so a equal to a plus 1, so a will be a plus 1. So now in the next loop a will be 11. Now check the condition. If 11 mod 3 equal to 0, no. If it is as it is false, the control will come to here. Now a is 12. Okay, now a is 12. So here the condition goes true. 12 mod 3 equal to 0. Yes, it is true. So as it is true, the control will be come to this block as it is true. So the statement is if a mod 9 not equal, so 12 mod 9 not equal to 0. Now see, it is true or false. Hello.
अब आ रहा है
12 mod 9 not equal to 0. It is true. It is true. That is 12 is not divisible by 9. So 12 will be printed. Okay. Then a will be increment. Then a will be here 13. So now again condition will be checked. It is false. Then a will be increment. Then it will be 14. Similarly, when it is 15, then see this will be true. So 15 mod 9 not equal to 0. It is also true. Then after 12, 15 will be printed. Okay. Now similarly, when a will be 18. Okay. Now see 18 mod 3 equal to 0. It is true. As it is true, this block of statement will be run. Now 18 mod 9 not equal to 0. So this is false because 18 is divisible by 9. So as it is false, so this block of statement will not run. The condition will come to here and here and then here, and then a will be 19. So our program is very correct because I have checked it by dry run. Now saving it. Now running this program. So you can see that all the two-digit number which are divisible by 3 but not divisible by 9 are printed. Okay, so as I said, we can do this program by two ways. Okay, so this was our first way. Now what is our second way? So similarly, in the last class, I have told you about logical operators, that is AND operator, OR operator, and NOT operator. Okay, so in AND operator, if both are true, then the as a whole it will return true. Okay, for more detail you can see the last class video. Okay, so now I am doing this code with second method, that is we will do nothing but simply this block of statement will be changed to a single line. That is, what is our condition here? Check. If the number is divisible by 3 and not divisible by 9, then it will be printed. So we can do it in one statement. That is, if a mod 3 equal to 0, if this is true, and also if a mod 9 not equal to 0, if both are correct, then only our condition will be true. So for that we will use AND operator here. Okay, because if both is correct, then AND operator returns true. So if both condition will be true, then print A. Now you will say, why don't we use OR operator here? See, if we use OR operator, then if 12, let's see, 12 is divisible by 3. Okay, so it will return 1, or 12 not divisible by 9, so it will return also 1. So 1 or 1 equal to 1, that is true, then A will be print. Simple. Okay, fine. Now suppose if it is 18. Okay, so 18 divided by 3, that is very true, so this will return 1. And or a mod 9 not equal to 0, so this is false, because 18 is divisible by 9, so this will return 0. So 1 or 0, this will return 1. Okay, so but this is not our uh, need. Okay, so we have to use AND operator, because if both condition will be true, only then A will be printed. Okay, so now running this code also, you can see there is no any change in the output. So moving to the digit separation program, the first program is write a C program to print all the digit in a number. Okay, so in that the logic of digit separation, I have been told you very clearly in the flowcharts. So I will just write a program here. So starting with our header file, then a number, a variable n to store the number, or then a variable to take the remainder, and that's it. Now printf give a message to user to enter a number, then store it into the variable n. Now what was our condition in the digit separation? That is while n greater than 0. The condition I have told you in the flow charts. So if you don't know these logic conditions, so please go to the flowchart video. So the condition in the while loop will be n greater than 0. In while loop, we have to take the remainder. So how we take the remainder? That is r equal to n mod 10. So this will return our last digit of the number. Because suppose if our number is 1, 2, 3, 4, 5. So if we divide this number by 10, then the remainder will be 5. Then the remainder will be 5. So 5 will be stored to r. So we have our last digit in the variable r. Then print it. That is %d, and then give a tab, and r will be printed here. Now what we do next? We divide n by 10 and store it to n. Okay. So now if we divide n by 10, so it may give floating value, but here we will take only integer value. So for that we have to typecast it to integer, and then our loop will be ended and return 0. Now print digit of number. I save this file and now running this file. So enter a number. Suppose I have given 1, 2, 3, 4, 5. Now the number is, the digits are 5, 4, 3, 2, 1. So this is our very small program in the digit separation. Now moving to our next program, that is to find sum of the digit of a number. So next program is write a C program to find sum of digit of number. So we will in this program we copy our previous program, that because this program will be very similar to previous one. Just instead of printing, we have to add the digits. So if as we are adding the numbers, so we have to take a variable s and initialize it by 0, and then s will be s plus r. And after the termination of loop, we just print this sum, that is sum of digit equal to %d, and s will be printed. So this program will be sum of digit of number dot c, and we run this program. Now giving the input 1, 2, 3, 4, 5. Now the sum is 15. You can count the sum, that is 5 plus 4, that is 9, 9 plus 3, 12, 12 plus 2, 14, and plus 1 equal to 15. So this is our very simple program of digit separation.